Why does SaaS AI cause latency for distributed teams? Imagine trying to have a conversation with someone across the world and experiencing a slight delay every time you speak. That's similar to what happens with SaaS artificial intelligence for teams spread out across different locations. When you use software as a service artificial intelligence solutions, the processing isn't happening on your local machine. Instead, it's on remote cloud servers. So every time you want the AI to do something, your device has to send data over the internet to those servers, wait for the AI to process it, and then receive the response back. This back and forth takes time, and that's where latency comes in. The main reason for this delay is the physical distance between your device and the cloud data centers. Data has to travel through multiple network nodes, which are like relay points on the internet. The farther away these nodes are, the longer the data takes to reach the servers and come back. This is called network distance and multiple hops. Each hop adds a tiny delay, but when you add them all up, it can become noticeable. Another factor is network congestion. The internet is often busy, especially during peak hours. When traffic is high, data packets can get delayed or queued, causing what's called jitter. This makes response times unpredictable and can slow down AI tasks that need quick data exchanges. Tail latency also plays a role. In distributed AI workloads, the overall response time depends on the slowest data packet or process. If one part of the network responds slowly, it holds up the entire operation. This is similar to a relay race where one slow runner delays the team. Cross-region synchronization is another challenge. When teams use AI models that operate across multiple cloud regions, they need to constantly share data. This ongoing exchange adds more delays because of the extra network trips and processing needed to keep everything in sync. Cloud infrastructure itself can introduce delays too. SaaS AI runs in virtualized environments where resources are shared among many users. This sharing can cause resource contention, meaning your AI task might wait for other processes to finish. Also, cloud systems often use network encapsulation techniques that add overhead, further increasing latency. Cold start latency is another issue. When AI models aren't running all the time, they need to load large files and initialize before they can process data. This startup time can add several seconds or more, especially with big models. Compared to on-premise AI systems, SaaS solutions are easier to access and scale. But they rely heavily on network performance. If your internet connection isn't fast or stable, it can cause noticeable delays. On-premise AI runs locally, so it can respond faster because it doesn't depend on data traveling over the internet. To reduce latency when using SaaS AI, organizations can choose cloud providers with data centers close to their teams. They can optimize network routes or use dedicated connections to improve speed. Caching data or preloading models can also help reduce cold start delays. Designing AI models that are less dependent on constant synchronization can make responses quicker. Monitoring network performance regularly helps identify bottlenecks so they can be fixed early. Overall, SaaS AI causes latency mainly because of the physical distance, network variability, synchronization needs, and cloud infrastructure overhead. Knowing these factors helps teams set realistic expectations and find ways to improve their experience with cloud-based AI tools.